Switching gears to some geometry topics. You can go ahead and flip your guided notes, or sorry, not guided notes, but your pink PSSA Big Ideas packet to the page front and back on geometry topics. Here we have a figure shown below where we have J and K are parallel lines. You can even see they look like they're parallel. They go completely horizontal. And we have this called transversal line M. Which equation can be used to find the value of X? Hit pause on the video, make your decision, and then hit play when you're ready to see how you did. All right, I hope you already did this problem on your own. Let's talk about this. This angle way up here, obviously an obtuse angle. It is bigger than 90 degrees. But this angle here is not obtuse. It is acute. It is less than 90. And what we know because of corresponding angles is that this angle here corresponds to this angle up here. And then from there you can realize these two angles, since they're side by side, making this straight line that we see as line J, straight angles are 180 degrees, which means this angle here, 2x plus 20, plus the x plus 40, because again, this angle up here that I made in blue is the same as this angle down here, x plus 40. So 2x plus 20 added by the x plus 40 should equal 180 degrees. That is obviously, as you can now see, choice D. Not choice C, it doesn't equal 90. Choice B is ridiculous, trying to take 2 times the smaller angle here. That doesn't apply to anything we ever learned here about angles from parallel lines. Choice A is wrong because they're trying to say they're congruent. That cannot be the case because one's obtuse, one's acute, so there's no way that they're congruent. All right. Speaking of parallel lines, this time we have 2 parallel lines M and N, and they are intersected by 2 different transversals. What is the value of X? Hit pause in the video, show some work on your scratch paper, figure out what the answer is for X, and then hit play when you're ready to see how you did. All right, did you already do this problem on your own? If not, you better hit pause now and do it on your own. Okay, so there's a couple ways of tackling this. We know X is up here. We can see 48's right next to it, but this time we got 3 angles. This guy here, and X here, and this unknown angle here, which I have no idea what that is initially. Those 3 angles together form 180 because the straight line M, straight angle is 180 degrees. So how do I get this angle here? Well, because of something called alternate interior angles, 72 degrees down here is the same as this angle up here, 72 degrees. So now I can see that 48 and 72 and X, those 3 angles, would add together to give me my straight angle, which is 180. So let's show that work. Add the 2 angles we know, 72 and 48, gives me 120. Then subtract that from the total of 180, because the straight angle is 180. That's going to give you a measure of 60 degrees for X, and that is choice C. Now, there is another way of tackling this problem. You might have noticed that we actually have a triangle here. Boom, boom, boom. Forgive me for not outlining this perfectly, but we definitely have a triangle. So, what do we know about the measures of angles in a triangle? They add up to be 180. So what we can do, again using the idea of alternate interior angles, is that if this guy's 48 degrees, then this guy here is 48 degrees, and now we have 3 angles, X, 48, and 72, that would add up to equal 180. Same work you already saw over here, and there you go, confirming our answer for X is 60. All right. What about this problem? The scale drawing of a triangle that will be used on a banner is shown below. Notice they are giving us the scale, and I'm going to point something out real quick. Sometimes in math, instead of putting an equal sign, we will use a colon when we are talking about scale. So please realize this is actually meaning that every 1 inch on this drawing is equal to 1.5 feet in actual real life. That's what scale means. Left number is the drawing's number, right number is the actual real life equivalent. Now, this problem says, what is the perimeter in feet? Notice we're not talking about inches. We want it in feet of the actual triangle used on the banner. Hit pause on the video, try this problem on your own, and then hit play when you're ready to see how you did. Make sure you show your work. All right, did you already do this problem on your own? If not, you better hit pause now and do this on your own. All right, so the first thing I'm going to do is I'm going to notice the angles. You see how this is y degrees and there's another angle that is y degrees? What that means is that we have what is called an isosceles triangle. Not only will there be two angles that are congruent, there will be two sides that touch those angles that will also be congruent, which means not only is this right side 5 inches, but the left side is also 5 inches. So that's the first thing you have to realize. But before you add these measurements together, let's use the scale. Every 1 inch is equal to 1.5 feet. So let's take the 5 inches, multiply by 1.5. How many feet do I then get? 7.5 feet. So what I'm going to do is I'm going to use my pencil here, and I'm going to cross out those measurements of 5 inches and replace them with what they are in actual real life, which is 7.5 feet. So boom and boom. What about the 6 inches? Go ahead and multiply that times 1.5. You will get 9 feet. So again, I'm going to cross out that 6 inches, and I'm going to replace it with 9 feet. Now, I know you don't actually have the drawing with you. You might have sketched it, though, at home on your paper. So now I know what the 3 sides are in actual feet. To get perimeter, all I have to do is add the outside measurements together for each side. So 7.5 plus 7.5 plus 9, boom, equals 24, which is choice B. And there you go. All right, one more problem for you. This one is going to be on cross sections. This says Barb has a jewelry box in the shape of a rectangular pyramid. The top opens at a cross section parallel to the base. That is definitely an important detail here. We're talking about cross sections, and we're talking about it being parallel to the base. All right, what is the shape of the opening of the jewelry box? Feel free to look back at the pink packet on the section, I believe it's on the back side of the geometry topics page on cross sections. Hit pause on the video, quickly figure out what the answer is, and then hit play when you're ready to see how you did. Okay, I'm assuming you already did this problem on your own. You can see here the opening is here. Now, from a three-dimensional point of view, this kind of looks like a rhombus or parallelogram, but you have to realize this was a rectangular pyramid, which means this base, even though three-dimensionally it kind of looks like it's a parallelogram or rhombus, it is not. It is actually a rectangle, because if it's called a rectangular pyramid, that means the base is a rectangle. This opening is parallel to that base, which means it should be the same type of shape as that base, except a smaller version of it. Because you can see as it goes higher, it gets smaller, that rectangle. Now, this is a rectangular base, so this is a rectangular opening. That's why the answer here is choice A. I know some of you might have been tempted to choose choice B because it kind of does look like a rhombus, but you have to realize perspective when you're looking at a drawing of a three-dimensional figure. Perspective matters. If you were looking at this cross-section straight on, you would see a rectangle, just like the base looking at it straight on would be a rectangle. All right, that concludes the video that I created here on a few extra practice problems for PSSA review. Thank you for watching and doing the problems on your own. We'll see you next time.